Understanding the normal curve distribution. This is the lesson that we will be talking about in this video. Now, let's start. In the previous lesson, we discussed discrete probability distribution, but this time, we'll be discussing continuous probability distribution that serves as a model in inferential statistics. Now, when scores in a set of data are ordered and their frequencies are noted, a pattern emerges. And to know this pattern, let's do the following activity. So first activity is all about visualizing a frequency distribution. So given the frequency distribution table of the scores in a mathematics test, which is shown below, let's do the following activity. We're going to order the scores from highest to lowest, which are already arranged, and then their frequencies are already noted. So the lowest score 15, it has a frequency of 1. So from the lowest score up to the middlemost score, which is 18, the frequency is increasing. That is 1, it becomes 3, from 3 it becomes 6, from 6 it becomes 11. And then from the 18 or the middlemost score going to the highest score, which is 21, the frequency is decreasing. That is from 11 it becomes 7, from 7 it becomes 5, and from 5 it becomes 2. Therefore, we can say that the pattern of the frequency distribution is in a reverse direction. So to further visualize this pattern, let's do the second and third activity, that is to sketch the frequency polygon of the data. So what is a frequency polygon? Frequency polygon is a line graph wherein we can create such polygon after connecting the points with a straight line. And then after that, let's describe the shape of the polygon. Now let's see what is the figure of the graph using this data. Here is the frequency polygon of the data we have a while ago. It seems to be like an imperfect triangle which depicts a hill or a mountain in a real life. Next, we have visualizing a normal distribution. So to do this, let's do the following activity. We're going to sketch the graph of the given distribution. This time we have here the scores of 5 students in a math quiz. Using this data, let's look at the figure of its graph. This is the graph using straight line. Upon using smooth curve, the graph would look like this. Now, let us increase the number of students to 14. Then observe what will happen to the shape of the graph. Using this data, the graph would look like this. So using straight line, this is the graph. Using smooth curve, this is the image of the graph. Let us now further increase the number of students from the first graph to the second graph and lastly to the third graph, which is already have 39 students all in all. The graph would look like this using straight lines. And using smooth curve, the graph is like this. Here, we have the summary of the graphs that we have on the previous examples. As you can see, as we add more data on it, the graph goes taller and slimmer at the same time. Let's now focus on the graph using smooth curve. The shape of this graph resembles a bell shape, which is one of the properties of a normal curve. And here is the first property. The distribution curve is a bell shape, as you can see on the screen. Then the graph is a continuous curve and has a domain wherein x is in between negative and positive infinity. It only means that the tail of the graph can be extended continuously to the left and to the right, and that the numbers here on the baseline or the values of x can be increased or decreased without any bound or any restriction. This time we have here the summary of the distribution that we have on the previous example. Our task here is to compute for the three measures of averages, the mean, the median, and the mode. And then let's have some observation. After having our observation, let's try to answer this question. What does it imply? For the first table, in computing for its mean, the first step is to multiply the score to its frequency. That is 3 times 1, 2 times 3, and 1 times 1. Then add them up. That is summation of f of x that is equal to 10. Then to compute for the value of the mean, the formula is summation of f of x divided by n, where n, the capital letter N, is the total number of frequency or the total number of population. Then by substitution, we have 10 divided by 5, that is equal to 2. That is now the value of the mean. And for the median, all we need to do here is to locate for the middlemost score, which is 2. That is the median. And for the mode, let's locate for the highest number of frequency, and that is 3. And its corresponding score is 2. Therefore, our mode is 2. As you can notice, the values of the averages here are all equal. Now, let's check if it's still the same on the succeeding tables that we have in the screen. Now for the second table, let's do the same process. Multiplying score to its corresponding frequency, that is 5 times 1, 4 times 3, 3 times 6, 2 times 3, 1 times 1, then add them up. That is equal to 42. Then using the same formula, then by substitution, we have 42 divided by 14, that is equal to 3. Therefore, that is the value of the mean. And for the median, locate lang natin ang the middlemost score, which is 3. Therefore, the median is 3. And for the mode, let's look for the highest number of frequency, which is 6, and that is 3. The score is 3. That is now the mode. They are also equal. And for the third and last table, same process again. Multiply score to the frequency, that is 9 times 1, so on and so forth up to 1 times 1. Then add them up. We have 195 as the summation of f of x. Then using the same formula, then by substitution, we have 195 divided by 39, that is equal to 5, which is the value of the mean. And for the median, let's locate for the middlemost score, which is 5. And for the mode, let's locate for the highest number of frequency, which is 11, and its corresponding score is 5. Therefore, the mode is also equal to 5. So as you can notice, the measures that the values of the three measures of averages of the three distribution table we have here are all equal. And that depicts our second property of a normal probability distribution. And here is the second property stating that the mean, the median, and the mode coincide at the center, as you can see on the screen. So we have here that the highest point of the curve occurs at x equals mean. So the mean here is 0, or in the middle of the curve. Now, for the third property, the curve is symmetrical about its center. So when you say symmetrical, the point here on the center serves as the mirror. So if it's the original object, the other side, its opposite, is its reflection. Therefore, the area of these two are all equal. We have 50% here and 50% on the other side. Okay, the fourth property is that the width of the curve is determined by the standard deviation of the distribution. So in our previous lesson, I have told you that standard deviation determines the distance of a variable from the mean. So here on the curve, we have the mean on the center, or at the center. So from this point, it dictates that it's one standard deviation away from the mean, and this point states that it's two standard deviation away from the mean. Okay, so that is how we are going to determine the width of the curve. Next, we have the fifth and the sixth. So the fifth property, the tails of the curve flatten out indefinitely or without any bound, without any restriction, that is forever, along the horizontal axis, always approaching the axis but never touching it. That is, the curve is asymptotic to the baseline. So meaning to say, the curve will continue to extend forever. Okay? But it will never touch the x-axis. So, magkikita lang sila, but hindi sila magdidikit kailanman. So, that is the property. So, the sixth property, the area under the curve is always equal to 1 or 100%. Thus, it represents the probability, the proportion, or the percentage associated with a specific set of measurement values. So, that value is what we call the probability, the proportion, or even the percentage. Okay. Now, let me tell you that the normal curve has a very important role in inferential statistics. Why? Because it provides a graphical representation of statistical values through its graph, which is the normal curve, that are needed in describing the characteristics of populations, that is descriptive statistics, as well as in making decisions, which depicts inferential statistics. So it is also defined by the equation that uses the population mean, mu, and the standard deviation, which is the lowercase sigma. And then there is no single curve, but rather a family of normal curve that have the same basic characteristics but have different means and standard deviation. Okay, why family of normal curves? Because each normal curve has a different values for the mean and for the standard deviation. Here is the formula defining the standard normal curve if we're going to manually graph our distribution. So here y is the height of the curve, particular values of x. X is any score in the distribution. This one, lowercase sigma, is the standard deviation of the population. Mu, the mean of the population. We have the pi and the constant e. So if x is equal to positive negative 3, here is the value of y. For x positive negative 2, here is the value of y. For x equals negative positive 1, here's the value of y. And for x equals 0, here is the value of the y. Using this data, if we're going to graph it manually or using graphing tool, the image would look like this. So here is now the standard normal curve using this formula. And for the areas under the normal curve, this is now the values. So we have here 68.26%, that is the area within one standard deviation from the mean. Okay, so each area, from on the left of the mean, we have 34.13%. To the right of the mean, we have 34.13% as well. That is symmetry. So within two standard deviation from the mean, we have the area equals to 95.44%. And then within 3 standard deviation from the mean, the area is equal to 99.73%. And on the tails, on the left and the right tail of the curve, we have 0.14%. So this is now the areas under the normal curve. Okay, so standard normal curve is a normal probability distribution that has a mean equals 0 and a standard deviation equals 1. So this is now the characteristic of any normal curve. For the next characteristic of a normal curve, it says here that the horizontal base, the x-axis, it contains the z-score values, refers to the numbers labeled on the x-axis. So those numbers is associated with areas under the curve, which I will be discussing on my next video. So I hope you learn something and you understand now the properties of a normal distribution as well as the normal curve. Thank you for watching and for listening.